Hi everybody. So today I'm going to be describing how to set up a simple Revolute joint. And as described in the introduction video, a Revolute joint is the hinge joint out of the multiple joints available to us in the Box2D library. And what we're going to do in this video is just set up a simple joint that'll connect two bodies together. And what I have is a box-shaped polygon and a circle-shaped body that I'm going to be tying together in different configurations. So you can understand some of the settings for the joint or for the Revolute joint. So first things first, there's three things that are fairly mandatory when setting up a joint. So let's get started with just getting our joint definition set up. And just like when creating a body, you have a body definition and you set up the properties of that body, the physical properties. So we're going to be doing the same thing. We'll just call this rdef equals new Revolute joint definition. And two of the three requirements is just figuring out what two bodies we're going to be joining together with this joint. So to access how you want to set which body is which, you get these public variables from the joint called body A and body B. So we're just going to set that to body 1, rdef.body B equals body 2. And then the third thing you're going to want to do is actually create that joint into our world. So that's rdef, just as we did when we created the body. So you have the world.createBody with the body definition, and you have the world.createJoint with the joint definition, kind of along the same lines, which is nice to see that familiar feeling available to us. So right now, the settings for my box and circle, the box is static, and the circle, the X and Y, is a little bit lower than the box currently. And another thing I'd like to mention before I run this is I have it so I get to choose when the world steps. Anytime I hold space down, the world will take a step for that frame. And I also have a configuration for if I press X, it will turn my box body, which I currently have as a static box body, so it shouldn't move. It'll turn it to a dynamic body, so it can move. But I wanted to have this world stepper so that I can show you the initial configuration and then how the Box2D world will resolve that initial configuration into the setup that we chose for the joint. It looks a little weird when you just see it snap to things, so it's kind of nice to see what it does before it starts working with that joint. So what we'll see from this is a circle that is at the y of 120 and a box that is at the y of 140, and they have the same x and y. So the box should be underneath the circle, and the circle should be just a little bit below the center of the box. And that's all you really have to do for this first joint configuration that we have. So let's load it up real quick. We'll kind of see that here, and perfect. And then I'll hold space down real quick right now, and you'll notice that after I did that, it snapped to the center. And to explain this a little better, I'm going to include another configuration variable that will allow you to understand why it snapped to the center after I allowed the world to run. So that variable is called collide connected, and typically the default for that variable is false. Now what that means is the two bodies that we joined will not collide with each other anymore. And normally in a Box2D world, any body will collide with any other body depending on its collision bit mask. And normally that is default where everything collides with everything. And so because this is initially set to false, those two bodies will not collide with each other. And because we join them, their anchors that they are joined at are the centers of the bodies. So I'll run that one more time so you can kind of see that, where the center of the circle gets moved to the center of the box, because that is where their anchor points currently are set to, and that is where they're going to join. There is no length on either hinge arm. Um, so that's why it kind of snaps to the center. Uh, and you wouldn't really get a chance to see that if the world stepper was just running every update frame, which is why I included this. And just to show you real quick, you'll notice that the circle starts right on the box, or gives that appearance of it starting right on the box, just like that. So just wanted to make sure you saw that, so you know how it sets it up and resolves that joint. Now, the reason we want to set that to false in some cases is so we can still get that 360 degrees of rotation without bumping into itself as an object. But in some cases, you don't always want that. So you can set that to true, and you'll notice that after I let the world run, the circle will actually be pushed out of the box as a collision response. But when that happens, there's a lot of tension on this joint, and that's not technically so good because these are supposed to be right on top of each other. That's a pretty big separation. So some weird things can happen as observed there when I turned it to a dynamic body. Next thing you're able to set are the local anchor points. Now, anchor points kind of establish how long those hinge arms are and what they will kind of rotate on. If you set one local anchor point, you'll see that you can do that by setting rdef.localAnchorA, and this will extend one arm of the hinge out to whatever point, and that is relative to the center of body A. So that is a vector2 object, and you can do that by just setting the x and y. And so we're going to want to just set that maybe 0 change on the x value, and let's put it 32 pixels up. And we'll also change this to be 140 as well, so they have matching x and y's, so we can kind of get a better idea of where we're putting it. And then, as before, you want to divide any information you're giving to the Box2D world by your pixels per meter ratio. And remember, any data you pull from the Box2D world, you want to multiply by the pixels per meter. Just always keep that in mind. And then when we do this, you'll notice that I have set it a positive 32 pixels in above body A from its relative center. So we should observe that the circle body will now be 32 pixels above the center of body A. And let's check that out real quick. Okay, so it did start there right now. However, when I press space, it should snap right back to where it's supposed to go, and that is perfect. So we can close that. Let's set this back to false also. Maybe run it one more time. Okay, and so we press space and it'll resolve the joint, and there it goes. It is 32 pixels above the box. And then if I turn the box into a dynamic body, it'll just kind of do as expected and fall with gravity. Okay, so now if we set the local anchor of B, this is the arm that comes from the body B, and it'll kind of meet with wherever the anchor A is extended to. So dot set, same as before, and let's extend this out to the right by 32 pixels. So we should observe a very kind of strange initial configuration. The anchor's arm will have it'll be extended out to the right, but also up, and it'll look kind of weird, but you'll see the way it resolves should give us the right appearance. Um, so what you see here is anchor A is established up here to this point. And because where the circle body is initially started at on top of body A, the box body, um, and we have the local anchor B extended out to the right from the center of body B, you'll see that it's trying to connect the anchor A to the anchor B by this diagonal line here. And let me press space real quick to see that resolve itself. You'll notice that it kind of snapped over to the right here. And because there was gravity already pulling on it, it kind of took it down a little bit already. And if I hold space, now we'll kind of just see it swing on that hinge joint. And this is essentially where the anchors will meet with each other. And that'll take a little bit of getting used to how to set that up properly with different types of bodies. But once you get it all configured right, then you don't really have to worry about it anymore. It just takes a little bit of messing around to really get used to how the positioning works. So we can kind of see how those bodies work together with that joint. Okay, and so that's all I really wanted to cover today in this video, and in the next video I'm going to show how to motorize that joint definition. And this is essentially how people will make simple wheels on carts or just very simple rolling objects on these circle bodies. And so with that, I hope you enjoy the video. Like, comment, subscribe as usual, and let me know how I'm doing, and let me know if there's anything else you'd like to know about these joints. Thank you for watching.